Welcome to Firestop Feed, the Pyrophobic podcast about passive fire safety solutions.
Overlooked, but absolutely critical for safety. Fire doors. Okay, let's unpack this a bit. Have you ever really stopped and thought about the engineering that goes into a fire door? Especially one that has to stand up to, over 1,000 degrees Fahrenheit?
That's right. Intense heat.
It's easy to just see them as, standard building parts, a
Yes.
checkbox, but really they're sophisticated safety systems, designed to be that first line of defense. So our mission today is to explore not just what makes them work, but maybe why some traditional designs are falling short, and how newer engineered solutions are, pushing the boundaries in fire safety.
That's a critical perspective. Because we're not just talking about a simple barrier here. We're talking about something that has to perform under the most extreme conditions. Picture it, a fire raging. That door might need to hold for 90 minutes, maybe more, at that scorching 1,000 degree mark. The challenge now really is that a lot of commercial doors still use these legacy designs. Developed decades ago. They met the codes back then, sure. But they often don't meet today's higher safety expectations or the demands of modern buildings.
That makes sense. Codes evolve, materials change, our understanding of fire improves. So let's dig into why those traditional options might not be cutting it anymore. You see a lot of standard 20, 45-minute doors using wood-based cores, like particle board.
Or agrofiber, stave core.
They seem simple, affordable probably, but what are the kind of hidden dangers when you need higher ratings? Like 90 minutes or 3 hours, we're basically uncovering vulnerabilities you might walk past every day.
You've really hit on a key issue there. Wood cores, they have their place for lower ratings, sure, but their limits become, pretty obvious under tougher conditions. First, their resistance to heat and flame spread. It's surprisingly low for real robust protection. But here's where it gets even more critical. Smoke containment. Often inadequate.
Smoke containment, right.
And this isn't just about ticking a box. It's a huge life safety risk. You might be surprised, actually. Smoke inhalation is often the greater danger in a fire. More fatalities than flames sometimes.
Wow, really?
Yes. So for modern safety standards, poor smoke containment is it's a non-starter. A common reason for failing code inspections. It's a big vulnerability.
That's a sobering thought, the smoke being deadlier. So, okay, it's not just about stopping flames. What about other core types? You mentioned legacy designs, things like honeycomb or steel-stiffened cores.
Right.
They're used for specific reasons, I guess, like weight or impact resistance. But what are their limits for fire protection?
Great question. Take honeycomb cores. They can be made of craft paper, sometimes steel, but under high heat, they can literally just collapse. Because they often lack any real fire-resistant fillers inside to keep their structure intact when it gets that hot.
I see.
Then you have steel-stiffened cores, physically tough, sure, very durable. But just to meet the basic fire tests like UL10C and especially the smoke ratings, they need heavy-gauge steel, extra reinforcements, additional fire barriers. It adds up.
So more complex, more weight.
Exactly. And the core problem, really, with both these legacy types, they don't consistently give you an integrated solution. They struggle with thermal insulation or meeting those temperature rise limits on the non-fire side, or just the smoke protection we talked about. So what does this mean? It means there's always a compromise, a trade-off.
Okay, so it sounds like you gain one thing, maybe flame resistance, but you lose out on smoke control. Or you get durability, but not thermal protection. Always balancing, always trading off. That sounds problematic when safety's the goal. Which leads to the big question, is there a way to, eliminate that compromise, get everything in one system? And that's precisely where these next-gen materials come in, like TemprCore from Pyrophobic systems. It's aiming to get rid of those compromises. And this isn't just another mineral core, right?
No, far from it. TemprCore is what we call an engineered composite system. See, traditional cores often rely on layers, right? Sheets of wood, mineral board, paper honeycomb, all glued together. TemprCore uses a proprietary formula, and it's fundamentally reinforced with fiberglass.
Fiberglass, okay.
It's not just adding strength, it's really re-engineering how the core behaves under fire stress.
Fiberglass reinforcement, that sounds much stronger, more stable. You also mentioned its monolithic structure. What does that mean exactly, and why is it such a big deal?
Right, the monolithic structure. That's a massive advantage, a real game changer. Imagine the core like a single solid block of material, not layers stuck together.
Okay, one piece.
Exactly. So it inherently resists delamination, layers peeling apart. And crucially, it maintains hardware anchorage. The screws holding hinges, panic bars, they stay put, even under intense heat.
Ah, that's critical.
Absolutely. Compare that to older cores that can warp, peel apart, lose their structure when things get hot. If your hardware pulls out in a fire, the door fails. Period. So that structural integrity is paramount.
That monolithic structure sounds incredibly durable, but for the manufacturers, the OEMs, safety pros, those certifications are everything, aren't they?
Oh, absolutely. Non-negotiable.
So what specific certifications does TemprCore have to back this up?
Right. Compliance is key. TemprCore holds UL10C certification, specifically for 1.5-hour and 3-hour rated steel doors. And UL10C is important because it simulates real fire conditions, including air pressure differences, which really affect performance. It's also approved under NFPA 252 for the whole door system. So manufacturers using it know they're getting a certified system.
We talked about smoke earlier, how it's such a critical weakness in wood cores and so dangerous. How does TemprCore tackle that?
Directly. It has UL 1784 certification specifically for smoke containment. That standard really evaluates how well it prevents smoke leakage. Air leakage, too. This is absolutely vital in places like hospitals, schools, where codes like IBC and NFPA 105 are really strict about smoke control.
Makes sense for those environments.
So when TemprCore is used with the right perimeter, seals the gaskets around the door, it fully meets those smoke partition ratings. Critical for corridors, escape routes.
That's very reassuring. Now, another failure point we hear about is hardware pullout, screws just ripping out of weaker cores. Does TemprCore solve this?
It really does. It boasts an impressive 150 psi tensile strength for core retention.
150 psi. How does that compare?
Well, many traditional particle board cores might struggle to get even a third of that. So hardware pullout is a common issue there. With TemprCore, the screw retention is so good, you actually eliminate the need for internal blocking. Those extra wood or steel pieces usually needed inside the door just to hold the hardware.
So it simplifies manufacturing.
Hugely. Yeah. For OEMs, that means simpler production, lower costs, and really consistent, reliable performance. And it's tested and certified for standard panic hardware, fire exit devices, vertical rods, rim exits, the works, ensuring escape routes function.
Getting rid of blocking. That consistency sounds key for reliability. What about protecting the escape routes themselves, limiting the heat transfer, the temperature rise on the safe side?
Another area where it excels, it's engineered specifically to meet those strict temperature rise limits. UBC 722, IBC section 716. The performance is quite specific. Only a 250-degree serif rise at 30 minutes and 450 degrees at first at 60 minutes.
And what does that mean in practice?
It means the safe side of the door stays cool enough for long enough to allow people to evacuate safely through stairwells or corridors without facing unbearable heat. It protects the path out.
Okay, so connecting the dots. Superior fire and smoke performance, no need for internal blocking, consistent performance, lower installation variability. It really sounds like it integrates everything, strength, fire integrity, temperature control into one core. A holistic approach.
Exactly. And it's versatile, too, which OEMs appreciate. It works for standard commercial stuff. Single seal doors up to 4 by 8 feet, double doors up to 8 by 8, even double egress pairs, also up to 8 by 8, using vertical rods, fire exit hardware, and astragals.
Astragals, that's the strip covering the gap between double doors, right?
Precisely. Often needed for the fire listing, so it covers a lot of common ground.
That handles a wide range of standard stuff. But what about custom projects? Oversized doors. Architects love pushing boundaries.
That's where the engineered system really shines. TemprCore can support engineered alternatives for custom needs. We're talking oversized doors, bigger than 4 by 8 singles or 8 by 8 pairs. Or projects needing heavier steel skins, say 14 gauge for extra durability or security.
Okay.
It can also handle custom hardware setups. Vision lights the windows and doors, side lights, transoms above the door. It can even be used in acoustic-rated doors for sound control or lead line cores for x-ray rooms or high-security areas.
Wow, so really adaptable.
Very. Though those specialized uses, of course, need specific UL labeling or a submittal review process for approval.
So it's not just one size fits all, but adaptable technology for demanding designs. That's a big plus for OEMs.
Definitely. And it works with standard steel gauges, 20 down to 16 gauge typically, heavier for custom jobs. The core itself is about 1.656 inches, 42 millimeters, making a standard 1¾ inch thick door. And despite being robust, with a density around 24 pounds per cubic foot, the weight is manageable, about 55 pounds per core panel, practical for manufacturing and installation.
Well, we've certainly covered a lot today. It really shows why innovation in something like a fire door core is so vital right now. We looked at how traditional cores, wood, honeycomb, even steel ribbed often fall short. Fire performance, smoke control, structural integrity. they have gaps.
Indeed. And then we saw how engineered solutions, like TemprCore from Pyrophobic Systems, offer a really superior approach. That fiberglass reinforced monolithic core, it's not just an alternative. It genuinely sets a new benchmark.
Yeah.
You've got the UL10C, UL1784 certifications, ensuring fire resistance, smoke containment, meeting temperature rise limits, and it fundamentally addresses those core issues like warping, delamination. That single block structure is key. And it minimizes smoke leakage worries.
Plus that impressive 150 psi screw retention. That changes manufacturing by ditching the internal blocking, streamlines things for OEMs, boosts reliability. It's a versatile system that holds up under extreme conditions, giving people critical time.
Right. For the engineers, the product developers, the safety pros listening, TemprCore offers certified performance that really exceeds the old benchmarks. It lets them build safer doors, faster, and with much more confidence. It's a real leap in passive fire safety tech.
So next time you walk through a commercial building, maybe take a second look at those doors. Consider what's truly protecting you and how innovation, even in a door core, can make that critical difference between safety and, well, potential disaster. What stands out to you as the biggest game changer we talked about today? Something to maybe look for. It's a powerful reminder, isn't it? How material science keeps evolving to keep us safer. This deep dive into advanced fire-rated door cores featuring the innovation behind TemprCore was brought to you by Pyrophobic Systems Limited.